we've got three speakers from Yale who all put in separate proposals that were all fascinating. And rather than have the invidious choice between them, I thought I'd cheat and just try to persuade them to do all three in one. So I think first up, well, I'm not sure who's first up, but I know that David Chirella is joining, driving the slides, and he's accompanied by Lauren and Greta from Yale. So I'll shut up, David, and pass over to you.
Great, thank you, Michael. And thank you everyone for having us. My name is David Straw. I'm the head of digital preservation at Yale University Library. And today, myself and my colleagues, Lauren Work and Greta Graff, will be presenting on three different automated workflows that we've developed for working in different areas. So after I provide a little bit of background about our digital preservation program, Lauren will present on a pre-ingest workflow for working with born digital materials. Next, I'll discuss a process for packaging and ingesting collection items in bulk. And last, Greta will detail her development of an automated file integrity verification process. Each one of us will talk about discrete workflows, processes that exist kind of completely separate from one another. And this is due to working with different stakeholders, different types of content, and oftentimes at different places in the data lifecycle. So in terms of background, the digital preservation program at Yale began in 2013. We started providing digital preservation services kind of en masse to users in 2016 when our instance of Preservica was put into production. We currently serve units and departments from across the institution, so both inside the library and archives and outside in our museums and galleries. We have a 5-person team where we provide support for all aspects of digital preservation planning, ingesting and accessing data held in Preservica. And we also support born digital accessioning and administer the Preservica system. We run the enterprise on-premises version of Preservica, and our local infrastructure is administered by our library IT DevOps team. Our production instance currently holds more than 136 million files with over a petabyte of unique data. And given the large number of different streams of data and different stakeholders, we very often reach for an approach to automate some set of bulk tasks as they arise. And many of these processes, especially in the ingest area, begin with some type of pre-ingest work. And to discuss that, I'll turn it over to Lauren.
Thanks, David. So as David mentioned, we support a variety of collections and a large number of holdings. And I'm going to talk in particular about an in-progress pre-ingest workflow that helps to address our born digital backlog at scale. Next slide. So like many organizations, Yale Library has a backlog of physical and digital materials. In this case, I'll be focusing on the backlog of born digital materials that were transferred from physical media and that are the product of years of hard work of archivists and librarians at Yale. So in particular, I've been collaborating with Alice Frail, who's a member of our team and born digital specialist. Among other responsibilities, as David mentioned previously, Alice runs the centralized digital media accessioning service at Yale. And if you're interested in the details of the work that Alice has done to build out the service since 2016, I would highly encourage you to read her blog post from June of last year that outlines the before and after of this service. It's both linked in the slide, and I'll drop the link a little bit later in the chat. But I give this background because I want to highlight how my developing preservation-related workflow is an iterative modular process, like a lot of other folks have talked about on this call today, that was built really on another iterative accessioning workflow. So this has really allowed us to be responsive and flexible to collection needs. Next slide, please. For the purposes of this talk, I want to highlight a few important considerations that went into building out and starting to build out this pre-ingest workflow. So structured information outputs, such as CSVs with descriptive and technical metadata from the media accessioning service, have been a crucial component that I've used for this workflow. We all love a spreadsheet, things like repeated fields, structured information, have really been key to help build efficiency and identify patterns for things like collection and scripting work, as well as help with ingest at scale into Preservica. A second important consideration for this workflow is that our Preservica instance links to archive space for this type of collection ingest. Archive space is our descriptive system of record in this workflow. So we pull in descriptive information developed by archivists from archive space as part of our ingest workflow. That's part of Preservica. And Preservica writes some basic information and digital objects for the ingest of materials back to archive space. So this is the step where it's really crucial to have the correct information, such as archival object IDs, packaged with content as it's ingested into Preservica. And these 2 points matter for this workflow for a few reasons. First, it's often easier to find and fix issues prior to packaging and ingest of collections into Preservica. While it's possible to fix things when they're in the system, of course, it can take more time down the road. And we really want to be able to work at scale for things like these large amounts of backlog materials and all of our ingests. And second, just because of the nature of born digital backlogs and backlogs generally, it's common for years to potentially have passed between the description, imaging, and processing of content. And it's entirely possible that potentially the arrangement or description has changed, which could impact that efficiency of ingest and linking back to archive space if we don't catch changes ahead of time. So next slide, please. So based on these considerations, this is the current iteration of this kind of initial start of this pre-ingest born digital backlog workflow we've been working out. So from that original CSV that I talked about, that's the product of the media accessioning service, I use the archive space API to check parent archival objects and retrieve their children, and then write these results back to a second CSV. So that way I can easily check between the differences in values that might be in the original CSV and the records that are retrieved more recently from archive space. If there's differences between these values, I would then flag the collection, do a review myself, and then check in with Alice about any updates that might be needed or questions we might have for collection owners. If no differences are present, I then proceed with some of our next steps for ingest into Preservica. Next slide, please. So we've just started using this workflow, and it hasn't yet flagged any collection for those archive space descriptive changes, but it's actually produced other really important feedback mechanisms that I plan to use to build into potentially modular scripts that we could use at scale. One of these mechanisms has to do with folders that have zero content in them. So in an early backlog collection test, we discovered that a folder that should have had content in it for Preservica ingest actually did not. And this was possible to double check because of that structured event metadata that's captured in the original CSVs. So event metadata is usually recorded for things like stream or image captures for media content, and have something like passed or failed in the metadata. And so meaning that a successful capture should have been present, and therefore there should have been material to ingest when there was none because we had a passed flag in the metadata. So that allowed us to now review and recall the original physical media to double check content imaging for the collection. And I plan to build in a simple logic workflow that could take this structured event metadata information that's present in the accessioning CSVs and compare it potentially to content directories or other things where we might want to flag discrepancies at scale in future. I also plan to continue to work to scale my work with the archive space API to more efficiently cross-check collection information, and will continue to really iterate with my digital preservation colleagues and collection owners for more feedback and development of this work. So I'm going to pass on to David, who's going to talk a bit more about bulk packaging and ingest into Preservica.
Thanks, Lauren. So next I'll be detailing a process for a set of tools that I developed for completing bulk packaging in ingest. So in our primary special collections library, there's a regular stream of new files created as part of a patron-driven digitization program. Following the creation of these files, most often shot by our digital studio, the files need to be brought into the preservation system for long-term preservation. Each of the new items needs to be packaged along with some identifiers to link back to the archive space instance or other descriptive system of record. Following packaging, files then need to be ingested into Preservica. And at the end of the process, our preservation held files are used as the source of data for adding those files into our library's digital collections access system. And that's a separate process run outside of the digital preservation unit. Given the regularity of new items and kind of a steady stream of things coming in, and the need to work across departments, I aim to design a process that would keep impact low on staff and external units that we're working with, and enable as much automation as possible, and really try to take on like the majority of the work within the digital preservation unit. So towards fulfilling these needs, I worked with stakeholders in the collecting unit to integrate our packaging and ingest workflows within their existing overall workflow for taking those patron requests, shooting them, handling the files, and providing some output back to users. In the diagram, steps 1 and 5 at either end, those are things being handled outside of the digital preservation unit, and steps 2, 3, and 4 represent separate scripts that I've written to handle different parts of the process. So in step 1, production and access services staff arrange files on network storage, following an agreed to naming convention that includes things like the archive space identifier. Step 2, this is a bash script that I've created to go through that network storage share, check each directory that corresponds to a new item, verify that the required structure and naming convention is being followed, and then create a row in a CSV file that includes information like the path to that file and storage, the identifier, and the title to be used in packaging. This CSV file is then converted into an SQL database to be used in subsequent steps. Next step, step 3, is our packaging step using a bulk packaging script that primarily automates the operation of our Yes Creator command line packaging tool. This is an in-house tool that I've developed for creating Preservica XIP v6 compliant packages for ingest. The bulk packaging script in this step goes through the database of staged items, sets packaging options from 2 different configurable sources. So both at the collection level with a configuration file for setting things like storage policies and security descriptors, and then also at the item level where options stored per item in the database will override any collection level option. At a minimum, we have a unique archive space identifier for each item. As each item completes packaging, the information about that SIP is then written back to the database for use in step 4. Step 4 is the ingest and initiation tracking script. The script pulls the package identifier from the SQLite database and initiates ingest into Preservica via an API call. The script then tracks the status of that ingest and the total number of concurrent ingests to allow some limiting, some throttling of ingest throughput based on the overall system capacity. Upon completion of ingest, a text file containing information about the item post-ingest gets written back out to the network storage alongside the original staged files. And this has been a meaningful way to make the status of the ingest visible back to stakeholders alongside the original files, and also incorporate some additional details that we use in our final step, which is step 5, where we take these item level text files, concatenate them into a collection level CSV that is formatted for our next step, the access system, to then ingest the files for patron use. So overall, this project has been successful in implementing a largely automated process for ongoing packaging and ingest of these items. some takeaways from the beginning. I focused on having really approachable interfaces, particularly at the beginning and end of the process, where we picked up from external stakeholders and dropped it back off to them. And this took the form of, relying on directory naming conventions, so that stakeholders were just moving things around on storage where they were already comfortable and providing them back a CSV file formatted for use in the next step in the process. Next, there's been a really big benefit realized with working with multiple small discrete programs that each do a single thing rather than one large program to do everything. This has reduced complexity when it comes to troubleshooting, and also allowed us to kind of iterate on separate parts of the process while others kind of run along in the background. And the last takeaway is this project has been pretty successful. We've put more than 250,000 files through the process in a relatively short amount of time and with very little human interaction. So it's largely fulfilling what we've set out to do. Next, I'll turn it over to Greta.
Great. Thanks so much, David. Hi, everyone. Thanks so much to Michael and the rest of the DPC for hosting this webinar series. I am really enjoying learning about everyone's workflows. So today I will be talking about how I'm leveraging ChatGPT and Python to automate file integrity verifications. So quick disclaimer, I am still refining this, so it is definitely a workflow in progress. Next slide. So to give some background, our digital preservation system runs integrity checks automatically. We have set these up to run through batches of files nightly with the aim of making it through all of our files on disk storage at least once per year, and also trying to minimize the impact on staff who are using the system during the day. So this has largely worked well for us, and we have been able to process a huge volume of files. So we went through approximately 95 million files last year, around 3,300 of which returned an error during that process. However, there have been some limitations in the current process that provided the motivation to then develop this additional workflow. So occasionally files will be flagged as failing integrity checks if there is a network connectivity issue or a timeout when pulling in files from storage. In these cases, that error is actually most likely a false negative. However, we don't have an easy way within the system to rerun a fixity check on an individual file. Rather, those checks would normally need to wait until that batch of files comes up again for its regularly scheduled check, which could be up to a year later. And waiting that long would potentially limit our options for being able to remediate any actual failures. So we decided to develop this separate process to do some checks outside the system, kind of fill in that gap. And then due to the volume of data in our system, there was a need to be able to automate that process so it would actually scale. And this work also builds upon some previous work that I had done to report integrity check failures in Tableau. Next slide, please. So I had previously used ChatGPT to help me develop small Python scripts that could be used for various file processing tasks, including checking fixity when I was moving files around. For this process, it would be slightly more complicated script, but I did decide to take a similar approach to start out. So my general process when working with ChatGPT for scripting is to try to break the project into smaller steps and then try to take a modular approach as much as I can. So using smaller scripts to do discrete tasks rather than trying to get a single huge script to do everything. And then I worked to develop initial prompts for ChatGPT, where I try to be as detailed as possible about what my inputs look like and what I need to accomplish with each of them. I'm also really careful to use placeholders for any confidential information rather than sharing that info directly with ChatGPT. And then I'll copy and paste the draft script from ChatGPT into a Python environment on my local machine. I like to use Spider, where I'll actually review the code and update placeholders and then do my running and testing out from Spider. Next slide. I'll also test on a small subset of data and use copies of the files, especially initially, rather than doing anything with originals. I'll note any errors or unanticipated results as I go along, and then I'll work to refine scripts iteratively with ChatGPT. So I'll send back error messages or additional changes that I need to make. And a couple of things I've noticed as I've gone along is that it's helped me a lot whenever I ask changes to ask for the full script back each time. That has really helped. So I don't get like a snippet of code back from ChatGPT and then have to try to find out where it fits in the original. And then I also use language in my prompts to tell it to change this thing, but keep everything else the same. And that seems to reduce a lot of the confusion if I get back something that looks different from what I'm actually working on. And then I'll gradually add complexity and continue testing as I go. Next slide. So applying this general process to this file integrity project, I broke down that workflow into the main steps that I would need to accomplish. So what my workflow is looking like at this point is that I take a CSV that lists the files that had previously failed those automatic checks from the system. So I already had this information from my Tableau report that I developed before. So the output from Tableau then becomes the input for my script, and it's really streamlined. The CSV includes the identifier for the file, as well as the original checksum from when the file was ingested. From there, I get an authentication token for the digital preservation system API. And that token does expire every 15 minutes, so my script has to go and refresh it periodically. Then the script goes to the CSV row by row and makes an API call to download the file from the system. It will make 3 spaced out attempts to download the file if it keeps failing before noting it as a failure and then moving on to the next file. Then I'll rerun the fixity algorithm and then compare against the value that was initially calculated during ingest. And then from there, I have it create a separate CSV where it records the outcome, so whether that fixity matches or not. So I'll have that for my record. And then finally, I have it delete the temporary copies of those files that did pass the verification. I learned that the hard way because initially I was having it keep everything and then I started running out of space. I was like, that's not good. So I adjusted it to do that. So the parts that I'm still being determined at this point is what those additional actions for the ones that are true failures are going to look like, whether we need to do additional verification or start some remediation action. And then also I'm working on a process where I can hopefully write back the results of this process back into Tableau so I can keep a record of everything there. So it's handling both the system generated checks and my additional verifications. Next slide. And then my next steps then are to complete running the script on our backlog from the previous year. And then, as I mentioned, determining options for tracking the results in Tableau, then working with my unit and the collecting unit to determine the remediation steps for any actual failures. And then finally, beginning to monitor and run this script on an ongoing basis so we can catch these things a lot sooner. Next slide. So that is all for me and our group, but we'd be happy to take any questions. And thank you so much for your time.
Wow. Thanks very much to all 3 of you there for sort of a whistle-stop tour through 3 very important areas and some interesting work. The applause has started quicker than I can prompt for it. I'm a little bit conscious of where we're at in the time. So has anybody got any questions or observations? I see Mary's put something about work on integrity checking, Greta, and yep, not sharing PII with ChatGPT is so important. Yes. Can I ask a very general question? Oh, hang on. Caitlin's come in. So do you know what the final action will be confirmed? Failed fixity checks. Will you re-upload or replace those files into Preservica?
Yeah, really great question. So luckily, like this process seems to be weeding out a lot, like the false negatives. So that was our big thing is first to really kind of cut down that number. But as far as those go, we're hoping in most cases we're going to have an additional copy or 2 on a different storage media. We'll be able to just heal it and probably end up having to re-upload, re-ingest. In some cases, we're hoping it's not many. We may need to go back to the collecting unit and just request that we repackage and re-ingest. But that's part of this impetus for really starting this process and monitoring it early, because that means that hopefully, we'll still have an additional copy that if we do need to go back through and re-ingest, we can. So it's really kind of that managing that risk part of it.
And Sarah's asking if your scripts, all the scripts that we've been talking about today are available. Are they public anywhere on GitHub or something?
That's a really good question. I know I'll let David and Lauren answer. Mine is not yet because I'm still working it out. But we could probably, share information upon request if we need to. But yeah, hopefully eventually we'll have more of them in GitHub.
Yeah, we have shared some of our packaging tool, the Creator, in the past on GitHub. The other scripts specific to the process I talked about today are not shared, but certainly could be if useful.
Yeah, and similar to Greta, I'm pretty early in my scripting and API use journey, but hope to share if it's useful to folks when it's a little more developed.
Andy's got a quick question about true positives, but I'll let that sit for a while because Angela asks about it's kind of the Python coding knowledge skills you've got. But I've got a kind of related but more general question sort of for David and all of you really. So are you sort of librarians and archivists that are skilling up in these areas and learning yourselves or getting training, or are you building a team of sort of IT expert coders who then sort of learn the library side of things? Which way are you coming at this problem from?
Yeah, I think we're a pretty good mix. I have a background in computer science, which has certainly helped with a lot of this work. And I'll answer. There's a question from Angela about. I'll comment on it, talking about Python skills that Greta may have leveraged in working with ChatGPT. And I'll just say that like this has been a really good opportunity with scaling up and using things like GPT, where we have a lot of skills and a lot of expertise like with the systems. And so it's almost the easy part is kind of the tech side of it oftentimes, or not the easy part, but that's the part that can be learned or that can be worked on. And leveraging kind of like the existing expertise allows us to do that, I think, pretty efficiently across the team, no matter what each person's background has been.
And what about you, Lauren? Are you a librarian through and through, or?
Yeah, I guess I'd say so. I definitely do not have a background in computer science, but it is important, I think, that the time and skill set building is definitely part of the work at Yale as well. And that's important, I think, for a lot of folks who need to focus on doing this work. But like David said, we also I think benefit of having some of this baseline. And yeah, I'm definitely learning a bit more as I go. I think potentially working, or especially for me, skilling up and working with APIs at scale has been, I'm a newer addition to the Yale team. I've been there for about a year plus now. So it's definitely been something that I've worked on skilling up, but librarian skills certainly help with this. And I can also pass to Greta as well, because I know she's worked on this in particular with ChatGPT.
Sure, thanks. I can touch on Angela's question a little bit. So I also did not have a computer science background at all. And I think for me, the benefit of being able to use, like, I really view ChatGPT as a tool, like any other tool, how we make use of it. But for me, it has really kind of freed up some of the initial time that I might spend on more syntax related things, where a lot of human error can really creep in at that point, especially if it was me trying to fumble around, like, where do I put this colon, or where so that has really allowed me. It's not a magic solution. So I'm not able to just completely take the script and then not have to edit it. But I will say too, like Chat, it's really good about adding comments into the code. So I'm able to pretty much see at a glance, okay, this is what this part is doing. And I had a little bit of familiarity from like a Java class that I think, so I kind of know, like a for loop and how that works, and the kind of the idea of like, going through a spreadsheet, iterating through row by row. So I think that's helped me as I've devised my prompt. I really didn't need a ton of just really deep knowledge on that part of it. It's been more just like kind of working out the process of really looking at what comes out of it, testing it a lot. I do that extensively on copies of files, especially if I'm doing something where I'm moving things around, and this was a little bit different because I was just taking copies of things that already existed in the digital preservation. So I wasn't worried about messing up an original file or anything, which made it really good to kind of use that as a test case to get it linked in with pulling API data. And yeah, it's been really great. A great question.
Thanks, Greta.